Oh, it's clicking. Okay. Now we're recording this. So this is being recorded.
Are you sure? Normally gives a warning that it's being
Well,
recorded.
I'm not using their recording mechanism. That's
Oh.
probably a good idea. Let me see. I don't know.
That didn't work.
I don't know how that. I'm just using what is it? OCB or OSB or OBS? What is the name?
OBS.
OBS. Yeah, OBS. I like it. It works real nice. So that's
I'm OCD about using OBS.
Yeah.
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 Well, there are 8 combinations there.
Yeah. Okay. Hello.
There should be a record option if you're an admin.
Yeah. Well. Okay. I don't see it yet, but that doesn't mean anything.
Okay.
Actually, the only thing that I've seen in my particular role this week is that I have the ability to let people join.
Right.
I don't.
They removed the recording thing, I think, a couple months back.
Oh, okay.
Off the feature, so don't.
All right. Okay. All right. So I was saying I didn't see it.
It has to be an internal system.
Okay. All right. Anybody want to kick out? Anybody they want to say anything to start off with?
I'll start.
Huh?
The only thing I can say is that I probably won't be here for the whole thing. I probably have to head out after an hour or so.
Okay. Well, do you have anything you want
to present?
You want to start off?
Well, I could get a gold star.
Oh, okay. Let's see it.
All right, I won't start off, but I can do it within the first hour.
Oh, okay. Okay. Fine. How about you, Kareem? You got anything you want to let us know? New season, right?
Gold star.
Kareem?
Sorry.
So
we
I'll
get
go.
the reveal on the next on the 18th. So I'll update you then.
Yeah, okay.
I'll just go real quick. This is Raspberry Developer.
Okay.
So I live in close to Boston,
Oh, okay. Great.
and prior life was a software engineer.
Okay.
Right now I am working on hand finger robots. So I notice all you guys are working on something with wheels.
Yes, mostly. But, that doesn't mean we're not interested.
Yeah.
And you have a strong Texas accent.
Yeah, no, that's not Texas.
I'm actually working with a hand doctor, so he's kind of guided me to what the degrees of freedom and things like that.
Yeah.
Okay with Arduinos and coding and servo motors and stepper motors.
Yeah.
So what I don't have and what I'm not interested in is 3D printers. I don't have one, but I'm gonna need a hand 3D printed. It's just a whole nother thing that I just don't want to learn. Not interested at all.
Mm-hmm. Well, I will say this, just on a side. It's not the pain it used to be. Most of the 3D printers that you buy now will work out of the box, which was not the case, 5 years ago. And the tools have gotten better, the slicers and whatnot. It's still a learning curve. And I can appreciate if you don't want to go there. But
I'm also a really, really, really involved ham. I love amateur radio.
Oh, okay. Cool.
Yeah. So that's my status, and I think I have the code already. I just tested with one finger. Um, so I'm almost ready to have the hand and fingers printed. I just want to the hand, to the wrist. I don't need the rest.
Is it
I don't hear very well, so I'm gonna do sign language. That's one of the goals.
Oh,
Yeah, I'm
okay,
not
that's cool.
Not interested in picking up anything, so it doesn't. I don't need heavy servo or motors. You know, something that's gonna lift. You know, not even 5 pounds.
Mm-hmm.
So.
But can you do sign language with just your hand? I always thought I've seen them do, you know, like all sorts of motions with their hands to mean different things, and that might be just shorthand, but.
Yep, no, finger spelling is with your fingers, but yeah, most sign language is with your hands.
Yeah. Mm-hmm.
Maybe that'll prevent situations. There's apparently someone who was signing didn't know anything about sign. I'm not sure. I don't remember where it was, but the comment was that if they were signing, it wasn't, you know, any sign language that most people knew.
Yeah. Yeah.
Are we rolling, by the way?
Oh yeah, we're
Yes.
rolling. We're rolling.
Oh,
Okay, so there you have it.
Yeah. So how are you how are you sending out to get your part? So I guess what I'm saying is, when you say you're not interested in 3D printing, there's more to it. That's kind of like the end. There's CAD design and other stuff in between. Are you doing CAD design of parts?
Yes and no. I've already bought a hand and finger off of Tinker Spear. I think that's the name of them.
Tinkercad or something. Okay.
It was a terrible design. I sent it back. Yeah. I could have modified it and made it work, but I didn't want to take the time. Not worth it.
Was it Thingiverse?
Excuse me?
Was it Thingiverse?
No.
Thingiverse has all kinds of...
Tinker Spear or something like that.
Yeah, I think that's for Tinkercad. You might look at Thingiverse. They do have you know, a lot of different models for hands and fingers and stuff. Yeah. I mean, I can't tell you my experience on models from other people, and particularly on Thingiverse. The first thing you do is you look to make sure they actually have a picture of it, because that means somebody actually made it. Because a lot of them, the models are never actually got printed, and so they don't really know if they would work or not. Yeah, and there are a lot of designs, and then I guess the other site you might consider to look is Instructables. They have a lot of, what do they call them, prosthetics hands.
Oh yeah.
And might give you that might have the same thing. So those two sites I would suggest. One would be Thingiverse.com, and it's Thingiverse, and the other one is Instructables, and that's Instructables.
Yep.
Both
I'm familiar with both, sir.
Yeah. Okay. Those are.
Thank you.
Those are very good. Yeah. Okay. Especially if you're gonna farm out the actual design. That way you get a chance to look at them and see see how that. And a lot of times there'll be little videos too, which can tell you what you can expect. Yes.
I was wondering what the reason for building a physical robot is if you don't need it to manipulate anything. Couldn't you do the same thing in a virtual environment and still have it visible for people to interpret?
No, that's true, but that's no fun.
There's more to it, but to actually do the designing is a big thing. I used to interpret for a deafblind, so
Ah,
This-
okay.
Yeah.
So the actual feeling the motions, possibly. Uh-huh.
Right.
So, okay.
That's
How,
challenging.
I don't know if you know it, but that's how
Helen
blind
Keller.
people.
Yeah.
That's how blind people sign. They put their hands over your hands.
Right. Yeah.
Okay. Thank you.
Okay. Well, if you, like I say, most of us aren't building hands. We have had some people who have built heads, but
Yep.
and we even had one person here. I don't know if he's in today, who builds spiders. So so anyway,
And here's one without wheels that I built.
yeah,
So,
yeah. So
for
there,
example.
yeah, there are. We
You
have.
can build it out of popsicles if you don't want to 3D print, by the way.
It might be good for that. That probably wouldn't give you the hand over hand experience, but it might help you work out your code without having to commit to your actual printing yet. You know what I'm saying?
Yep. Yep.
Yeah.
Okay. Thanks, guys.
Okay. All right. Let's see. Ted, you got anything you want to go ahead with?
Yeah, I've got some stuff here. Let me present my screen.
Okay.
I am going forward on next year's Robo Columbus already.
Okay.
So, what I did is, one great thing about the robot I built is it's easy with those rails with all the holes to just bolt stuff on.
Yeah.
So, I ended up, I was having trouble with the getting this motor speeds working right, and so I just took off 2 of the wheels and put on a caster wheel on the back for trailing. So here's the test I did, and one thing, my electronic speed controller has a mode where you can feed it the quadrature encoders, and it'll figure out the speeds for you. So you just tell it the speed you want the motors to go at.
Yeah.
And that actually worked a lot better than the PID loop I was implementing. So I don't know, I was having trouble with the PID loop. I think I must have messed something up, because it is working great here. This was just running open loop from the robot. The speeds of the wheels are closed loop, but the actual heading is open loop. So it doesn't turn perfectly, but I've got going at a real slow speed here, a lot slower than I was running it before, and it's working just fine.
Well, that's great.
Which
Yeah.
motor controller are you using?
I'm using the Robo Claw.
Oh, okay. Yeah, like the 8 amp or the 15 amp.
Yeah, actually I'm using the 45 amp, because I had bought it for a different project and decided not to use it.
Yeah, it makes it pretty easy, doesn't it? I mean, you can even have it calculate the PID coefficients if you want.
Yeah, and that's what I did, and it's real nice.
Hey, Ted, what RPM are those motors, just out of curiosity?
They're 415 RPM
At the shaft? I mean, at the motor, at the wheel shaft?
at the wheel shaft. Yeah, that's the maximum speed.
Okay.
Wow.
Fast.
Yeah, very.
Yeah, I was able to control them going way down, nice and slow. So.
Okay. Now, burp is the same type of configuration. That's Scott Gibson's good robot, and his some things that you should be aware of, especially with that particular caster. You can easily get stuck in a hole because it's not powered.
Right. Well, I don't intend to run it that way. I'll put the other 2 wheels on. I was just having issues, so I took them off just to simplify things.
Well, you know how David does it. He had all the wheels on his all of the wheels are driven, and all the wheels on his side are powered by a single motor.
But yeah, by a single motor, I saw that.
Yep.
And the other thing you can do is you can have your powered motor wheels, but also just take that same wheel and mount it on the caster yourself, and that way you have the same size wheels all the way around.
Yeah, I'm hoping to go back to 4 wheels, maybe even 6 like David does.
Yeah.
His is an impressive robot. And
Yes, it is. And
Yeah.
hopefully next year he'll be up and running on it. You know what he did? He decided to upgrade his robot to a new controller, and in the process, he's had to tear up his working robot to make it new, and that's painful, real painful.
Yeah. I was talking to him. It sounded like his old controller was from like the 90s.
Yeah.
Or
I think it was actually. I think he started on that like in 1999 actually.
Yeah.
Yeah. So the other thing I have to show here is this was what John talked about a couple weeks ago, the Strider.
Can you move it just a little bit over a little bit? Not, yeah, there you go.
there you go.
The Strider legs. And so I went and 3D printed a set of them. They are really small though. I'm trying to figure out how to scale them up. I think I'll just have to go into CAD and remodel everything. But yeah, just turning it by
Well, you
hand is
could-
kind of a cool motion.
You should be able to, when you 3D print it, just scale up the whole thing, right?
Yeah,
I mean, your screws will have to be bigger, of course.
the problem is it scales up everything. So things like
Right.
inside out. Let's see. I'm going to take out this.
We're to the other
There's
side.
that-
There you go.
There's that circle
more.
there.
Right.
And there's a bearing that goes in there, and have to get,
And trying to find a
resliced-
bearing to match, right?
Yeah,
that
exactly.
problem.
That's the problem with
Unless you
scaling
3D print the bearing, but
Have you
Yeah.
guys seen, there's a website that was it's still around and it's posted by a Russian guy and it's in Russian unfortunately, but it doesn't really matter, and it's basically a animation of all the different constructions that can be used to create motion, and like different lever arms, and you connect them all in different ways, and it shows you the particular pattern that you get from this particular construction of arms. I wish I could remember where that was from, but it was basically that you might call technology that was used to create those big what were the ones that ran on the beaches called?
Strider.
Yeah, the Striders. So this is like a website that describes the mathematics of those particular constructions and all the different kinds of constructions that particular mathematician had invented, and shows how they actually move. And so you could effectively choose which of these different constructions you want to get a particular motion.
If you, I
I
Yeah.
can find it. Yeah, I know.
yeah, Ted, you might be able to do what John was saying, which is scale it up either at the printer or in your CAD program. If you're using Autodesk, or not Autodesk, what is it? AutoCAD 123 or what's the name of it? 360. AutoCAD 360.
Yeah, Fusion.
Yeah, Fusion 360, excuse me. If you're using that, you can probably scale it up. The places where you'll run into trouble are either shafts or holes, because they'll scale up. You probably don't want to scale them up at the same rate that you're scaling other stuff up.
Yeah,
But you can take them out of your model and then add them back in when they're finished.
Of course, the problem is that on places like Thingiverse, people only publish the STLs usually.
Yeah,
So you don't
but okay, now
have
here's a little, this doesn't always work, okay? But both Fusion 360 and FreeCAD have tools to take an STL file to a step file,
Ah, cool.
or whatever format you want. 360s is you probably have to Google it, because it's pretty complicated how to do it. FreeCAD is pretty easy. Now the big problem you run into when you do that is if you have a big curved surface, when it was made into an STL, those are all faceted. Otherwise, if you have a cylinder, it's no longer a cylinder, it's a faceted cylinder. And so when you turn it into a step file, it's going to be, those areas are going to have high facet counts. Now, both programs have an ability to simplify, which kind of works. depending on what you got, you can get there. But if you get close, what you can do is then you can impose a cylinder over, like sort of like, think of it like lining a cylinder or something. You can just take a new one and just kind of impose it over, and when it merges with the model, it'll actually be a cylinder. But depends on how much work you want to put into it. But I would check the easiest one is FreeCAD, and I suspect that they have instructions on how to do it. It's not very hard. You go to parts, I believe, and you make a solid out of it, and then you do a few other things. It's very, click, 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 and you've turned your STL into a step file.
Yeah, Fusion 360 is kind of complicated because you got to turn off history.
Yeah,
and do
yeah.
other things, but once you get it into a solid body, from that you turn everything back on, and you can do all the stuff you're normally used to doing.
And it also has it has a tool that's unique to Fusion 360 that I know, is that if you have a lot of surfaces that are on the same plane and they're faceted, you can just click on them, and then there's another button you push and they all turn into one flat piece. So don't give up just because you can't get an STL. Okay?
The thing I play with a lot is Design Spark, which is a very useful tool, and it will also import STL files.
Yeah, but it doesn't have a tool to convert them into a step file.
True, but you can manipulate them in Design Spark.
Yeah, yeah.
And once it's there, you can actually overlay your design using the dimensions of the original, basically.
Yeah, so there's lots of things you can do in Design Spark, and I find Design Spark is very easy to use.
Yeah, it's what I use. I use it all the time when I'm CADing, but that's because I'm too lazy to learn Fusion. But I use OpenCAD only for conversion, not to actually to generate, to create. I don't create I create in Design Spark.
So Dave, I think we're getting echo from your.
I'm sorry.
Okay. Ted, so how did it work?
So yeah, I got it working, just the one pair of legs. I haven't printed in anything else. My 3D printer isn't quite up to the. It's so small. My 3D printer has trouble with the with the precision of it. So it doesn't turn that great, but I was able to get the one set of legs to turn.
Cool. Be interesting to see when you have a couple more going, but yeah, I guess the main thing, at least when I saw it, was the fact that the leads are so relatively small, they don't reach up as much, and so hence it looks more like a inchworm type movement, where it's more down to the ground movement.
Yeah, I think the point was the legs kind of go down, then they lift up and come over and go down again and lift up and go over. And so they're not like sweeping, so they come up more, so they can step onto things.
So it'll be interesting to see, especially if you can scale it up a little bit. Yeah, I was thinking that even.
Mm-hmm.
Yeah, right now I'm working on tuning up my 3D printer to print a little better. I think if I can.
So what type of what type of filament are you using? Is it a 1.75 or is it a 3?
Yeah, 1.75
so
PLA.
A relatively small filament.
Yeah.
Which give you better layers. So cool.
Mm-hmm.
I'll show one thing while I'm on it. So let me show the thing that I found once I click on the right button. Okay. So back to the fingers things. So depending upon what she was thinking of, there's this one out there where you can do frets. So it has the different fingers. And then that's one. And then there was one. So were you thinking actually that you would move it, or Rodrigo or Raspberry would move it, or what? How would you think you were going to use the fingers?
Yeah, with servo motors.
Because I was going to say there's that one, but you see that one is more where you would just move it to whatever precision you want. So you're after more along the lines
She
of
wants,
servo.
yeah, she wants more automated than that.
Yeah, there's one or two out there that I remember, but I don't see it right offhand.
Does anybody remember that one robot that the guy built that made out of kind of a milky white 3D printed, and he built a whole torso and hand, but he started with a hand?
And I think it's called...
Yeah, I'm not sure if he's on tonight.
No, I don't think he's here,
on
but his
first.
robot's on YouTube, and he
Yeah.
actually has hands. He's
That
got a
one
hand
right there.
that's very functional.
Okay, this is it. I think the InMo. That's the one you're talking about, probably. And this is the hand that goes with the...
Yeah, that end move has got little tendons on it that
Right.
they have some alternate photos, and you can see the little tendons that they're running through the wrist area to operate
You
the
can
fingers.
do that.
So each finger has a strand for gripping and one strand for straightening and everything. So you can connect that pair of tendon wires to a servo and get independent control of each finger.
So yeah, this is probably the best one
Well,
Site is
out
this?
there.
that's Thingiverse.
Thingiverse thing
Okay.
17773 is what you will want
Okay.
to go to.
Thank you.
Is that sufficient degrees of freedom with that mechanism that you can only curl the finger?
Well,
Right.
that's how you do
No,
it, right?
no.
With your hands.
No, it looks like if he's talking about the one he's showing, it looks like you can also the palm can close too. You see, there's a joint there along the diagonal. So a little more there.
Yeah, I know, but there are more degrees of freedom in your finger joints than just curling them.
Yeah.
And there's also, and separately from that, there's also a splaying action that may be important for signing.
Yeah. I don't know enough about signing to know.
The Vulcan Salute there.
Yeah,
Yeah, exactly.
But this is the one that I've seen that's the most sophisticated. And you know, they even have a face on that with it, as you can see.
Okay. Sounds good, John.
So, okay. Let me undo this. Did it close?
Not yet.
Okay, well, I'll just close it that way.
Okay. Great. Let's see. Hey, Ray, you got anything you want to say?
I saved a lot of money with Geico Insurance. No. The my wife and I went camping this past week, and we actually had reservations for 3 days. I think it took 3 days to get ready to get everything in the camper. We stayed there 2 out of the 3 days, but it was so hot. It was like you couldn't do anything outside. It was just like,
Yeah.
just sopping wet. So, and then it takes another couple days to unpack. So,
Yeah.
and that brings me to today.
So was it packed at was it a state park?
Yeah, it was Tawakoni State Park. Kind of weird. Most of the park was reserved, but there were virtually no trailers. So everybody, and this was Wednesday and Thursday. We actually left Friday, so I don't know if it was going to fill up over the weekend. But
Well, if it's tested, so you can reserve it like 3 months or 4 months ahead, so people do that, and then the cars don't show up because it's raining or something.
yeah,
So yeah, that I've noticed that.
so we're gonna wait a month and then probably go again. So, but kind of fun getting the thing back up and functional again. There's just a lot of things. You know, we had to get another trailer hitch, put that on. Had to check out the air conditioner, make sure it was working. It worked for most of the night, but I don't know if it was running too long, and it was, you know, it was kind of a little on the noisy side. So I think it may need a new run capacitor, because over time it starts to run rougher and rougher. And you know, so at one point we just have to turn it off, but by then it's cool enough in the morning, early morning.
Yeah.
But nothing to do with robotics, but that's what I've been with.
Okay. Well, I was going to ask Kelly what he had to go there, but he stepped out. So let's see, David, do you have anything you want to discuss? You're muted, David.
Nope.
Okay.
Not at this point.
Okay. Harold.
Who, me?
Yeah, you.
Oh, you guys gonna let me talk? That's crazy. What are you doing?
I know, but
You know better than that. No, I really don't have a whole lot going on. Believe it or not, I've been working on my Mr. Bighead. It was pretty successful. It's being pretty chatty, and things are working fairly smoothly on that. As far as robotics goes, I haven't done just a whole ton of anything other than get to dreaming about what I'm going to do for my outdoor robot already next year, even though I don't know what the contest is going to be.
it'll be the rules will not change, but the course will change.
Of course, change. Okay.
Yeah.
So I still think the plan of finding a 1/8 scale or a rock or a one of those 1/8 scale things, or a rock crawler in the same vein as being the base chassis on that thing, so I get a roller. I think it's a pretty good start. I mean, in fact, I found one that actually was really good, but I'm not paying $1,000 so I can tear it apart. You know, I'm just not going to do that. However, I hear that if I look around enough, I might be able to find either some cheap Chinese knockoffs that will do my job, because a lot of these things that I'm looking at, they're beefy and they're meant to go 50, 60 miles an hour over just any damn thing that runs in their way. And
Once.
Doing that, yeah, they can do it. Yeah, you know, they're designed to go 40, 50 miles an hour, and I think if I go over 10, that's too much, because I can't keep up with the damn thing anyway.
Yeah.
And that's just not going to be good. And so we won't have that speed or whatever, so I won't have those actual requirements that I need to have that. I'm looking for more of size and things where I can upgrade, make the springs stiffer and stuff, because I know I'm going to put a lot more weight on this than they initially intended for this vehicle to have.
Kareem actually did use a rock crawler at one time. He might be able to kind of let you know about some ideas that he ran into. I know he didn't show up with a rock crawler, but Kareem?
The previous version of the robot that I have, I still have the rock crawler, and it's actually a lot more capable than the thing I showed up with from a physical platform, as you'd expect from a commercially developed thing. It's a large one. It's a 5th scale rock crawler.
Ooh.
It's really big.
Yeah, it's hard to find. There's like 2 that I've been able to see over the last few years that have been in that scale, and one of them sold out right now. And they're at that scale. They're a bit more pricey as well.
Yeah.
But the real rock crawlers are not designed to go 40 miles an hour, right? They're all about torque and about slow manipulation. So they can still go faster than you can probably walk or maybe even run at top out, but they'll have the torque to go real slow and still move under their designed weight limits. The problem is going to be that they're designed to be very, very light, right? So even the large ones, most of the mass is in the wheels, and the rubber. I mean, there's some in the frame, but like the springs are designed to carry very light loads, So once you start weighing it down with robotics equipment, and I'm not even talking about things like an arm, but just the weight of the extra controllers and some servos for a pan tilt head and things like that. You're getting outside of the initial way that they were designed in terms of carrying that little plastic shell of a cab. And so there's certain things you have to do to compress the springs or upgrade the springs, but it'll get you a real durable platform that's perfect for outdoor transportation.
One of the things that helped solidify this with me is when I rolled into Hobbytown, I guess about a week or so ago, and I think I told you a little bit. I told this, last week a little bit about that, but I was just really, really happy to see the availability of parts and pieces that not all of them will fit everything, but being able to Frankenstein stuff together and heck, even change the viscosity of your oil if you get a big enough shock. That's crazy.
Yeah, there's a lot of options out there.
A lot of options and a lot of things. It's one of these things where my initial thought was, I've got this thing, and the only parts that are ever going to fix this thing is this whoever makes the thing, and that's certainly not true.
Especially at 10th scale and maybe even 8th scale, there's a much bigger market for those things.
Yeah, and so the thing that I'm thinking in my head, and I'm already thinking stupid stuff in my head, wondering if I've got to look around, the pan and tilt's going to come into play really, really in a major way, because in my Rover it'd be easy enough to put it in spin mode and just spin, so I don't care about that. But in this case, I got a 1/8 scale. I got to worry about turning radius, and all that sorts of things to figure that part out.
Yeah,
But
you do.
your idea of an arm there, Karim, you spoke an idea. If I've got to touch the cone and I had a lightweight arm that was just powered by 2 or 3 little servos that didn't need much weight on it, dude, that's a thing.
That's an easy thing to do, and I would just use. I would not sure I would call it an arm, or more like a movable whisker. You could put a thin carbon fiber rod on a servo and have it extend out pretty far, and just fold it back in the body like a wing until you need it, and then just zoom 2 of them out from either side, and as long as it hits something, you're good.
As long as it hits something, and I don't knock anything over, that's even better, right?
Yeah.
Hey, Kareem, could you put the maybe the names or the links for those 5? Okay, I've never seen one on a 5.
Sure. Yeah, I can find them.
Yeah.
And I'm thinking it's a pretty good platform. I'm also thinking about what my next project is going to be on my stream. I'm torn between building a lightsaber and doing something else, and I got plenty of toys back behind me to play on. So,
so you don't plan to take Exomai any further?
Zemo. I intend to keep on working on Zemo, but I know that Zemo and that Robo Columbus thing are not compatible. I just would not be competitive enough in what I need to get done. I can't make the thing go fast enough. That's one of the reasons. I just can't make it go fast enough. It's going at what I can put speeds at plus and minus 100 on it. Currently, what you saw over there was speed 50, and knowing what I know about speeds and motors, if I turned it up to 100, I would not get double my speed out of it. I'm pretty certain about that. And so it's just not going to go fast enough for me to get enough points to even compete with everybody else, and I would like to be competitive. And so, but Zemo is going to hang around. I'm going to continue working on it. What I want to do with Zemo is take a step back. I want to upgrade it to ROS 2. I want to do some other stuff, get all the GPS and all the other noise working for me, and also keep it around to be able to start building my show-off stuff. So, because I think it's a real showing-offy kind of thing. It drives with a joystick, or we can have it do some autonomous stuff eventually. And I think that'd be really cool if when we get to meeting in person again, some more Robo days or hanging out. I remember it used to be once a year everybody go to Tanner's and show their stuff off, And well, of course, you can't go to Tanner's anymore, but I'm sure we can find some outlets.
Well, there's Moon Day.
What now?
There's Moon Day.
Oh,
which
Moon
will be
Day
next year.
Yeah, next year. So I mean, it's a real interesting looking robot, and it deserves.
It'd be great for Moon Day.
Very
It'd be right in the theme.
Right in the thing.
Yeah.
And it deserves to be upgraded and get all of its pieces and parts working, and so I can show it off. And because I think the platform's really neat, and I think it's very capable. It's just not going to win me a Robo Columbus. It's probably not going to win me a Can if I ever got a Can. And as far as following a line, I don't see. It could probably follow a line, but it's just so big. I don't know that it would actually fit on the course with it. You know. So.
Yeah. I see
a lot
it.
of capability, right?
Yeah.
Are 1/5 size cars like the size of the little ride-on toys for children? Not the size of a 1/5 scale. Huge.
Say that again, Ray. I'm sorry, I couldn't hear you.
Is a 1/5 scale, RC car about the size of a ride-on toy, children's, young children? The ones that's battery powered.
One of those if it's 1/5 scale, I bet it's the size of one of those kiddie cars. I think you're right.
Yeah.
I don't think it's that big.
Not that big.
No, I want to say that Kareem's was probably about this big.
I just posted a link to it at
Yeah.
noonday.
Yeah. Okay. Cool.
A YouTube video of it at noonday.
Yeah.
So you can see how big it is.
Hey Ed, you raised your hand. What you want to say? Ed. You're unmuted. Unmute your mic if you're talking, Ed.
Sorry, I was actually trying to reach for the next button over so I could read the text.
Oh, okay.
Sent.
Oh, okay.
I'm sorry.
Okay, no problem. All right.
Doug, I did have one question about competitions, and I know that most of the competitions in the Robo Challenges are based on performance, like speed. Are there any that are more like deliberate? Like I just bought some really slow motors. I would never win a competition with those motors, but are there competitions that are more about like deliberate or careful movement or anything like that?
The problem is yes, there one that comes right to mind is Foursquare. All right, that's where you go about. You have 4 markers that are set in a cone. 4 markers that are set in a square. You start in a place. The guy puts a little tiny dot on the floor, probably on a piece of tape, and that's the front of your robot. And you got to drive around the square, and it's how close to that dot you get. And you can't use a camera to be looking at the floor.
Yeah.
Okay, so and people just using highly tuned odometry easily get under a ½ inch. Around a ½ inch, it gets a little hard for the judge to even tell, who won. So usually we just say if you're under a ½ inch, you win. You know what I mean? But we've had some people use some really fantastic different methods. So it is possible if you let us know, because sometimes the markers, the 4 corners, are little yellow cones, but sometimes they're little dots on the floor, and so cameras may or may not work for you. Otherwise, if you're looking forward and you can see where the cone you started at, and you say, okay, I got to match this picture, and you get it around. That's another way of doing it. But you got to get around the square to do that.
Right.
And you also have to, if I remember right, you get around the square and you have to do a turn. Otherwise, if you just go around the square, the front of your robot will be not in the right direction. You still got to do a 90-degree turn to bring it to the dot. So there's one. Now, but here's the problem with that now. All right, let's say we have 5 guys all get within a ½ inch. How do we tell number 1? Okay, well, and that's the problem with all of our contests, I think, is that if everybody gets what we consider a perfect score, then it defaults to the next criteria, which is who did it the fastest. Okay, now, but does that take away from anything? No, I don't think so. I mean,
Yeah, that just means somebody went out and bought faster motors.
well, yeah, and they're all tuned up if they. I mean, otherwise, so what I'm saying is the potential to win straight out with a slow motor is there because you could be closer than anybody else.
But that wouldn't be true on Robo Columbus, for example.
Well, now the way there is, I was going to say there's going to be a slight change. We'll probably incorporate the three waypoint challenge into the points system. So right now, you can waypoint your way around obstacles and get 9 points, and that's considered a perfect score because you haven't gone for the 3 waypoint challenge. But the 3 waypoint challenge will probably bring the perfect score up to 12. So and it will inflate a person who's waypointing around because he'll still be stuck at 9 because as soon as you use a 4th waypoint, you can't go for the 3 waypoint special. So that's probably a small change that will be made in the rules, but it's just scoring. It's not. So the question there is, so let's say, and this is not unbelievable, especially with this group, I could see 2 or 3 people getting perfect 9s next time. All right, and maybe one person getting a perfect 12. So if you so the guy who gets the perfect 12, he would be 1, and the guys that got the perfect 9, they're going to fight it out. Well, it'll be who did it the fastest.
Yeah, but from what I saw, there's a decent chance no one gets a perfect 9.
That's right. And the first time I competed, Ted, there were 3 competitors. The other 2 got perfect 9s, and I got a 3.
Oh, wow.
Yeah, I mean, so it's just who I can tell you. If David and Scott are on it that day, they'll perfect it out. The only reason why Scott didn't do it this time is because the wind was screwing up his ultrasonics. And if you think about the course, there was no solid trees. They were bushes. They were trees, but you know what I mean. They were soft targets. They would have been, from an ultrasonic point of view, they would not have been a reliable ultrasonic target. You might have been able to get it. You might not have been able. It's like hitting a chain link fence with ultrasonic. Probably ain't going to happen. You know what I mean?
It would work with the Polaroid sensors that David had.
Yeah, what David had, but so I'm still looking for that perfect, no matter where you are, it works system. And the only thing I can see is the LiDARs. But the LiDARs, their biggest problem is, they're probably a dot like this at 12 yards, as opposed to a cone that's like this. So you just have to. That's what makes it fun, guys. And by the way, SRS has something they call Robo Realm, sometime once a year. Yeah, right now they're kind of squirreled up, but out of COVID. And part of that is what they call Robo Magellan, which was done way before Robo Columbus, and it's a slightly different scoring, different purposes. It's more of for a person who's advanced to a certain degree. The other one is you can get a point, you can get 2 points, you can get 3 points. Theirs is a little tougher, and it's run once a year I think in the fall, but I'm not sure exactly when they run it. It might be in the spring. So there's another contest that if we get good and we get a couple of robots that are doing nice, maybe we take a group trip up there and show them how it's done. Anyway, we'll see. We got to get it done first. So, But so anyway, I think I went on that question.
Yeah,
So-
but I think you could show up with a really slow robot and do well in the contests that I've seen. You
Oh,
know,
yeah,
you might
yeah.
not win, but you could.
A perfect 9 score is nothing to sneeze at.
Yeah.
I mean,
Yeah.
it's not. I mean, that's great.
I think the thing is for me is I've kind of committed. I actually just made a big expenditure the other day and bought a whole bunch of stuff from GoBuilda, and the wheel size is not going to be much bigger than that, and so it's not really going to be an outdoor robot that runs well over grass. I'm thinking about manufacturing like 100 mil, like Mars Rover style wheels. And then I think it's possible to go outdoors, of course. It won't be climbing over big stumps or anything, but certainly over grass it should be fine. But with these wheels, no way. They're not going to go over grass very well. And I bought 52 RPM motors.
Whoa, looks like Doug's got some big ones. Yeah.
That's
Yeah.
Honolulu wheels there.
These to go build the 22 millimeter motors, and I got the 52 RPM ones because they have like, I can't remember what the torque rating on it, but it was like a monster for such a small motor because they're so small. But it's not going to be a racing robot. It's more Mars Rover, slow, deliberate movement kind of thing.
Mm-hmm. Well,
You know, I think David Anderson would tell you that going slow is better than going fast.
yeah.
Well, the way I looked at it is that a 52 RPM motor, that's top speed, and you probably won't run it at top speed anyway. So let's say you're running it at 40 RPM or even 30 RPM. That's 2 revolutions per second. Or no, a half a revolution per second. That's still pretty fast. I mean, that means that if you've got a 100 mil wheel, you're going about that far in 1 second. So that, that's top speed. That's pretty fast for a Mars rover. It's not a racing robot, but it's a reasonable top speed. And but it won't be, it won't be competitive speed at all.
Well, you have to worry about object avoidance at that speed because you're seeing it and poof, you're hitting it.
Yeah, exactly. That's one of the things I've found is that, the infrared's in the front of my robot. If I'm running the robot too fast, there's no way the robot can stop in time, even if it sees something.
Yeah, that's a problem. Yeah, so I agree with Doug's statement that, there is an optimum speed that you should design your robot for. Because, if you get 8 points, it doesn't matter how fast you got there. The guy that got 9 points still beat you. So, anyway.
Maybe I'm just not competitive enough.
Yeah.
I'd like to see the Micro Mouse guys define optimum speed.
Oh, well, theirs is faster the better, yeah. That's really crazy. Well, also line falling in the Far East. Line falling in the Far East is like, it's like a blur. It's just incredible. When I watch those videos on YouTube, I'm totally amazed.
Guy does a 40-foot course in less than 3 seconds.
Yeah. Well, there's even the European. There's a college level line following contest in Europe, and if you watch those guys, they're rocking too. Yeah. But anyway, and for your question, Murray, just one last point. The challenge line following course was to take speed out of it. That was what it was designed originally. One of the goals it had was to take speed out of it. It was also
it still had a minimum finish time.
It does, but I think it's like 15 minutes or something. I mean, nobody runs into that, So, but I mean, but it was meant to. It was important to finish, and again, if somebody else finished faster than you, but so far nobody has done that.
Well, I like the idea of making the course start out easy and get progressively harder until at the end it's almost impossible, so no one ever finishes. That'd be a cool course.
Yeah.
Yeah, and then it's just whoever gets the closest to the end. Yeah, I like that, Ted.
Well, the last time we ran the challenge course, that's what we did. We pretty much people were allowed to assist their robots. but the number of assists that they made counted against them. And,
You mean like carrying it to the finish line, you mean?
No. Like
Yeah.
if they lost the line, they could sort of like what is it? You take a penalty point when you hit thing out of off in golf, and you mark where it left the course, and you bring the robot back to it, let it go again. But that
mulligan.
Yeah, and I don't think you call that a mulligan. I think a mulligan is when you do a shot and you just take it over and you don't count the penalty.
Oh, okay.
Yeah.
All I know about golf is it's frustrating.
Yeah.
Yeah, pretty much mulligan, do again. That's
Yeah.
pretty. I was explained to me.
Yeah.
So
Okay.
I might make another run at that challenge course. I just bought a fancy new line following array from Pololu today because they had yesterday they had their 4th September 6th sale going on.
Yeah, Labor Day.
Yeah. So we'll see.
Yeah.
I'll get that hooked up, see what I can do.
Yep. Yeah. Let's see, Raj, did you have anything you wanted to say? He might have stepped away. I don't know.
I can show and tell real quick.
Okay, great. Go.
Let me disconnect this. This will be quick. This is, oops. Sorry, got to answer questions here. This is Telepresence Robot.
Okay.
Getting back far enough to see it.
Yep.
And
Nice.
I can turn it on with the switch. And it moves around. And I can turn it off. And so far, that's all it does.
Looks like it has plenty of power.
Code. That's just the motor testing code there. So
Yeah.
next step will be to actually make it do what I want it to do.
Okay.
So that all the electronics work now. The power turns on, the motors run. I just have to hook it up with all my telepresence smarts now.
Mhm. Hey, Raj, go ahead, Doug.
That was all I had.
Oh, okay. Raj, you got something? Let's see what you got.
All right, so here's a old project, not a recent one, but it was a weekend project. So I have a bunch of foam core boards and 2 motors,
Yeah.
a wheel.
Yeah.
Currently charging. So here's all the what do you say? Just tape and foam board and hot glue. What does it have? So it has these 2 are simple motors, the cheap ones that you get in Amazon or stuff. I tried to put in a battery, 18650 battery, 3.7 volt battery here. This is a booster, supposed to convert 3.7 to 5 volts. And then I have an Arduino Nano and LM328 LM298 motor driver chip here, which is I think 2 amps per motor. And I have a Bluetooth receiver here. So just wanted to put things together and just run it just for fun. And I also have a USB charging board, which charges the battery.
Cool.
So this is a simple one, and how do you control it? If you ever want to build something you want to control with Bluetooth, there's a free app called Lofi, and it's pretty straightforward. I powered up the remote, thing, and I connect to the Bluetooth receiver. There's a Arduino code that you get, which you push, burn it onto or deploy it onto the Arduino Nano or Uno, and then you can control it using the joystick here. Let me see if it can be done. I think a bunch of wires came out when I remove this. Let me see if I got the wiring right. Yeah, okay, that's working. So
Put it on the floor. Put it on the floor. We want to give you a gold star here, guy.
All right, so let me see. I don't know if you can see the robot.
Not yet. Oh, there it is. Got it.
There it is.
Yeah, we got it. Hey, it's moving.
Yeah, it's still not charged, so I'm connecting the power cable there.
Yeah, I see it.
Yeah. And there are a bunch of nice modes here. You could like change this to the gamepad mode, or you could change this to rotation using the IMU of the cell phone, and you can just drive it around like that.
Yeah, that's nice. Raj, can you go ahead and put the app name in the chat?
Sure. I will do that.
And just to clarify, that app connects to any Bluetooth robot?
Yeah, so there are a bunch of chips. I think the common chips, I don't remember the names now, but that like a year ago, I guess. But the most common chips that you get, the Bluetooth chips on Amazon, you could use those. Let me type in the app name. So just make sure you get the app, and then you get the compatible Bluetooth receiver, which is most of the receivers that you find on Amazon. And just hook it up to Arduino Nano or Uno. Take the Arduino file, flash it on it, and it understands the commands. You just have to configure the motor connections. If you need a couple of like LEDs or something, you have a bunch of. I think there are two buttons on the app, and you can just use that app to connect to the robot and control it. And I think if you use the Bluetooth 4 or 5, the newer version, you don't even need any passcodes to pair with it. So you just turn it on and just hit the hit the Bluetooth to connect on the app, and it just talks to it. There's no ping or anything like that.
Yeah, I do want to make sure, Doug, that if you go after this, you want to get a Bluetooth module, probably that's at least a 4, version 4, because the phones now are dropping support for the older ones because they use too much power. So, they'll work fine with Arduino and stuff, but if you're going to use a phone, you need one of the newer modules.
I think the ESP32 has Bluetooth and BLE.
Mm-hmm. Okay. Let's see, Ed. I know we talked a little bit before, but do you have anything you want to say? Ed? You're muted, Ed.
No, not at this time. Thanks.
Okay, great. Neil, how about you? You got anything you want to add? Okay. Neil, you're muted, so we don't know if you have something or don't have anything. Okay. Wait a minute. We're moving to the next guy here.
Doug, while we're at it though, before we get too late, let's talk a little bit about Saturdays.
We'll do that in a little bit. Okay. I'm sorry I don't know how to pronounce your name, so I'm going to just say Thal.
Yeah, I go by Kumar.
I'm sorry,
I go by Kumar. And previously, about a couple of years ago, I've attended some of the DPRG meetings. I live in Allen, Texas.
Okay.
And just about a couple of months back, I said I wanted to get back into robotics. And currently, I'm very interested in the Rover, but I don't want to spend money. So, I'm going with some cheap servos and for the steering, 4 of the steerings. And I am 3D printing parts at the Frisco library here. And at the base, I also have some Adafruit motors, which look like a servo, but are continuous rotation motors. and I'm planning to use the Cricket and the Circuit Playground Express. The Cricket has two drives, and I'm planning to do all the left three motors all the same and the right three with the same drive. So I don't have multiple 6 drives, I have only 2 drives. And for the steering servos, I went with the MG996R, and I'm going to have 4 of them. I kind of know a little about programming, but not much, and I just want to get something assembled and see it moving. And I created a 3D printed part, and it came with a lot of these white things on it. And they said that you need to kind of heat it a little to remove it, these extra things which come on the 3D printed part. And I put it into a microwave and it all melted. So I'm like, I'm not supposed to do that. I'm supposed to heat it a little. And I just came to see about this meetup and thought I'll just listen in today and see what people are doing.
Okay.
And it was fun to listen to what people were talking about. I'm not a full-fledged roboticist or anything. I just thought I'll play around and do something, and have started working on it.
Okay, well, join. You're welcome, and I want you to know that I recognize you once you put your screen on, just get one built. You know, anything that moves, that's the first step. You know what I mean? And then once you get it moving, and like Raj showed, even foam board is an excellent lightweight material. I mean,
Ray, I have something which can get me a gold.
Yeah.
And what I did is in Thingiverse, I found parts for the Cricket thing.
Okay.
And I printed those 2 parts, and I have it just moving forward with a IR sensor going forward and backward and forward and backward. And I think Murray, I'm on a personal robotics group. He said, you got a star. And I think he got the star information from DPRG. Nice meeting you guys.
Okay.
That's correct, actually.
Okay. All right. We just had somebody join in late. Since K, I guess you go by K or Abilus. Guys, I'm sorry, my pronunciation is horrible. So.
I think that's Abbas.
Huh?
Abbas.
Abbas. Okay. Hi. Do you have any?
It's Abbas Sayed. Yeah. So that is correct pronunciation.
Yeah.
I just wanted to join. Yeah. I'm sorry. What, you were saying something?
I was just wondering if you had anything you wanted to share with the group.
Well, so to start with, I am here in Louisville, Texas, and I'm an engineer, and I just have a long lost robotics background. I saw this group in Google, and right now I'm doing totally different thing, Android development. So just wanted to have a touch with my last memories of robotics. I did work in avionics industries with some 3D on a 3-axis table that would test aircraft's parameters like roll, if I remember, heading, and this. So I just wanted to have a touch and be a passive member for some time.
That's fine.
Get back to get something, really restart something.
Well, we'll keep throwing challenges out there, trying to get you excited, and maybe you can. We'll see you at one of our competitions.
Sure. Yeah, that would be great.
That'd be great. Okay.
Thanks.
And Android is a usable robotics platform, so
yeah,
that's what my team uses.
Yeah.
Great. Yeah, great to hear that. Thanks.
All right, let's see. Did we miss anybody? Because I'm going to go next if anybody... Oh, okay. That's good. All right. Some exciting news. Some really exciting news. Then during the last week or so, Arduino released a version for the Pico, and so did Platform IO. So now it's very easy to program a Pico in C or C++, and you do have the Arduino environment that you, excuse me, if you're in Platform and IO, you still have the same famous Arduino commands that you all love, but you don't have to do that. Raspberry Pi has put out a Pico tools or an SDK for the Pico, and it's very well documented. And what I'm finding is, let me see if I can show this. All right. Do you guys see this? It's not very exciting, but you can see that there's a green LED and then a red LED and then a green LED and then a red LED. Ah, he's got two LEDs working. Wow. One is on.
Hey, that's my favorite program. I like writing that.
The red LED is working on core 1. The green one is working on core 0. That's not so obvious, but that's being done using the Platform IO. It's really pretty neat. If anybody wants any help, the only gotcha I ran into in setting it up was there was one program that's called RP 2040.x or something like that. I didn't catch it at first, but my antivirus program flagged it. And I tell you what, I spent a day trying to figure out where is this program? I can't find it. It keeps telling me that I'm missing this file, and I keep looking around, and then finally I looked up on somebody's comment. Well, we found that several antivirus programs are flagging this, and we're working on whitelisting it now, and I'm sure it will be. But I just went into my particular version of antivirus, which is WebRoot, and asked them to whitelist it, and after that I haven't had any problem with it disappearing. So it's very cool. I'm going to share something. Share. Okay, let's see, is this, I want to make sure. Okay, so this is the program that this guy happens to be running on. You can see I've identified two, and I've created a Core 1 entry. And this code actually came from some YouTube, so it's not like I'm really smart or anything. But so I set it up, and this is where it sets up it launches the Core 1. And what it's doing here in the loop, it's handling the green LED on pin 25. But you see it's also doing a multi-core FIFO push, and it's a blocking call. And what it's doing is it's pushing on a 0 onto the FIFO of the second core. And then this one is pushing on 1, and then this program, it says as while true, just pull things off, pop things off of the multi-core FIFO, and then do it. And that's why if I change this to 1 and this one to 0, they would do in sync. So it's very basic, but let's see, but it's kind of cool. You can see this is in one of the things that you have to do is you have to put it in program mode, which if you've played with the Pico, you have to do that. So that was a big one, and that now makes the Pico, the $4 dual core processor from Raspberry Pi, very usable for even Arduino style projects. something to think about, guys. Then the second thing I'd like to talk about is an interesting program that I ran into when I was on the SparkFun channel. It's called Flow Code. Not Code Flow, but Flow Code. And it's out of England. And what it does, let's see if I can get it. Let's see if I've got it running here. It's essentially one of those programs where you put in a flow chart. You put in your flow chart for the program, and then it creates all the code for you. You know, it'll all go all the way down to it'll do assembly or C or whatever, and it'll turn it into a hex file, and then you can run it on your program. So let's see if I can bring that up.
So you're talking about the old IBM, where you have a square that represents the process, and
Yep.
another square with, or diamond.
Yeah, for decisions and stuff. And I gotta admit, I'm not so sure how useful it is because of. Let's see here if I can get to it.
I think I've seen ads for this in Circuit Seller magazine.
Yeah. Well, code. You got to be careful. There's a whole bunch of them. It's the one by Matrix TSL. This is them. So let's see if I can get to flow code. Come on. Yeah, come on, come on. See if I can get it. Nope, nope, nope. This is not the page I want to show you guys. They're reworking their website, and they just happen to be doing it right now. So let's see if I can find it. No. Let me go back to the, maybe this is not it. All right. Well, I don't know, guys. I'm not being, but they have.
Just put a link in to one of their how-to things on the chat.
Oh, did you? Let me click on that then. Maybe that's what we need to do.
Doug, I think I found the website, matrixtsl.com. Take a look at that if that's the one or not.
Yeah, well, if you want to go to the buy, you want to go to the buy, is what I wanted, the buy tab. And they have a free version for 30 days, and they have a hobby version, which I'm not sure what it costs. They have limited functionality, but they also, let's do this. Oh, it's not going to let me do it. Where is...
I googled matrix flow code and it came up.
Okay, well, let's try that.
I clicked on that flow code programming. That's not actually the same page I got, but you probably could do learn the program with flow code.
Yeah, let me Arduino is one of their programs, so maybe this is it. let's see. No, there's still not. I'm still not getting into the actual flow code. But you can, if you can get to their, okay.
You're on the right webpage.
Yeah, but there's a page where you can see all of their options. For example, like if you wanted the flow code version that would handle STM32Fs, they have a module for that. And see, oh wait a minute, here's by. This might give me where I wanted to go. See what I mean? It's all broken right now. But if you find the exact link, you can get into it. And it looks that they have, let's see if I can, okay, do you guys see this? They have another option, which I think they call it App Developer. And this is an example of where I've got an Arduino hooked up. And let me see, I'm going to drop out of, so see what I can, this is just a demo program. So like here I've got this one shorted out and you see it's 0. That's a to D. And here you can flick out. You see how number 7 went off, and when I put it on, it goes back on. That's because I've got D10 hooked up to D7, and I have a little LED on this PWM, and you can change the version. And this is actually, from what I can see, it's actually a compiled app. Now this program's another 50. They like 50 pounds. That seems to be their big thing. But if you were working with an ESP32, they actually have a free module, and they also they give you Arduino Uno for free. So that's kind of cool. It might be worth, if it interests you at all, it might be worth looking into. Okay, so those were two things that distracted me this week. But I was really pleased to get the Pico where I can screw with it. And the other thing I did was, and this is in anticipation of what I'm going to do on Raj's idea. You can see here these areas right here. This is, I've mapped out all my sensors out onto a big piece of paper, so I know where my dead spots are and what the cones are. So that's all. I did that this weekend, so I'm getting pretty ready for that. And the first thing I'm going to do, Raj, is I'm going to try to implement a version of adaptive mapping. But it's going to be really, really simple. It's following one of the instructables that's out there. And I'm just going to, I can't copy his code. I'm going to have to, his code is very specific to the robot he built. But I'm trying to capture the ideas. And essentially what he does is he puts a robot that's 6 blocks away, or 6 cells away, and he puts different things in front of it, and the robot finds the path through all of the obstacles and gets to the end point. And it's using a wave, what do they call it, waveform, where it propagates a path from the target to. Now there's it's a very limited concept because your map has to include your goal and your personal location, and I don't want to have a humongous map. So what I'm going to be doing is sliding my map along, and the goal location will be actually a vector pointing to, because I'll have the heading of where my robot is to the waypoint, and it'll be using that to to move where the goal is, and so it'll be trying to, get to that. But anyway, I'm starting. If you got any good links or anything that you would suggest for reading material, I don't need, if it's got humongous matrix notation in it, I'm probably not going to read it. It's got to be something simple, like dead simple. But any of you guys have any mapping pieces of information, I'd like to get it, because I'm hoping to get that in pretty quick. So that's what I've been doing this last week.
A quick comment on that Pico. I've seen where they have somebody's been using Python for it.
Oh, it was originally came out in a Python. It's got it comes out when you buy it. It comes with, well, I don't know if it comes with it or whether you load it in using Thorny, or I think it's called Thorny. They have a software IDE that you can load MicroPython straight onto it. And that's great, and I have nothing wrong with that if you want to take that approach. But I was looking more for a substitute, a fast processor, powerful processor that I could use in my robot with using C. And I think now that this nut's been cracked, I think you'll start seeing quite a lot of C programs on it too.
Okay.
But you can still, still can use MicroPython. It's a great chip to learn MicroPython on. Because, MicroPython, it's got classes called machine and everything that are routines that are specifically for that particular processor. And that's how MicroPython can go from chip to chip to chip to chip. They have a couple of classes that contain all of the basic subroutines. So, anyway.
So don't forget to put the link for that Instructables in the chat.
Oh, okay. Yeah, okay.
Can you repeat your question about mapping or maps, Doug? I'm not sure I fully caught that.
What I'm saying is, if you got a good, nice, oh, you mean what I was doing for mapping? Or I made a call, if you guys got any resources, simple resources on mapping, and even if you had a simple resource on SLAM, that'd be fine too. But you got to remember, that's another reason why this Pico starts to come in. If I'm going to be doing mapping, I need probably more horsepower. I can, yeah, go ahead.
I don't have a resource per se, maybe just a keyword. You may already have that, but there's different types of maps, of course, but occupancy grid is probably the keyword you should look into if you haven't already. That's one type of map that's pretty popular now. It's potentially a little bit of space hungry, so that may be a concern depending on how big your grid is. Yeah. But conceptually, it's the easiest type of map, at least for me, right? You have, depending on what kind of sensors you have, and if you're looking at something, and kind of where your sensor is hitting the obstacle and where that is relative to your robot. If you have that information, right, you basically populate that occupancy grid accordingly as you just move along. So,
okay, here's pretty much what I've got. I've got horizontal and vertical and 45. Now, obviously, because 45, you have to, factor it by 1.44. It doesn't go as far. But that's every time I get a sensor read, I should have these available squares. All right. So that's what I'm hoping to. And these two extra ones that you see up here is if I decide to use the ultrasonic. It sees a little bit further than the IR ones.
Oh, I see. So these squares represent
represent
the sensor
grids.
arrays.
Yeah, the grid. Yeah, they're the sensor array. But they show you the blocks in the grid that I could see potentially from my starting location. Then I have to make a move and reassess. And so, if there's an obstacle in the way, I won't see all the way to the end of these. I'll see some shortened version. I'll put a wall there.
Yeah. So, I mean, this is kind of one of the dilemmas is that I've found, right? So I went down a path a couple of years now trying to implement some occupancy grid scheme myself, and that's when I then kind of decided, you know, maybe I should look into ROS, because now you're getting into this space where, you know, some of the building blocks are there for you to just utilize in ROS. Obviously, it's just such a big step up, and we've talked about that so many times, but you're kind of in this gray area. You need just maybe some simple mapping, right? But you know, implementing all that from scratch, it's certainly going to be a lot of work. There are some libraries out there, and they may even have been mentioned here, that do some of those pieces for you. You don't have to sort of go the full ROS route. MPRT, or those same 4 letters in a different sequence maybe, is one of those, Mobile Robot Programming Toolkit, MRPT maybe. Okay, that's what I'm thinking. So that's one sort of library that I have looked at many years ago that gives you in a lot of the routines that you need for some of this stuff. So that's another keyword to look at, MRPT.
Okay, got it. So, okay, those are 2 good thanks. I appreciate that. Now, let's see, I was going to get that instructable for you guys here. Let's see if I... Okay, this is the one that I'm trying to replicate. This guy right here. Now this is very basic, so don't expect a whole lot out of it, but this is a start, and this is what I want to start with.
Like, are you sharing your screen or?
I'm putting it in the chat here. Okay. All right. Okay, so this is, well, I don't know, did it? Oh. Okay, so this is the, okay.
There's 10 mouses waiting, hovering over.
Okay, there it is. Got it. So, yeah. So anyway, this is the instructable that and he's got a video, and you can watch that. And like I say, this has a lot of once you start looking into it, there's a lot of limitations to it. But if you can do this, you're on your way, you know. Now, let's address Chris's idea. The problem I have with ROS, really, not for me, and when ROS 1 was really going, I was looking at it pretty seriously. But the problem I had is if everything in ROS works, it is fantastic leg up, because you're standing on the shoulders of multiple giants. The problem is if it doesn't work, you're squirreled, because you have no idea what the heck's going on, because you don't know the algorithms they're using, you don't know anything. So
yeah.
So this is one of the problems, you know. Now, we've had club members who actually contributed to ROS, so you know, it's not, yeah, Jason and also Paul. So it's not undoable. And ROS 2, I don't, you know, I just know that it's ROS 2. I don't know if it's better or worse. The problem is you can't really stay with ROS 1, because ROS 2 is getting all the work done on it. So you got to go to ROS 2, and I'm not sure if that's easier or harder. Listening to Harold, it sounded harder. So
Actually, I talked to a couple of guys, and currently ROS 2 is where the new hotness is.
Yep.
But the majority of people that are out there doing it commercially are ROS 1.
Yeah, well, that's
the vast majority. It's like 10,000 to 10, kind of majority kind of thing.
Well, that's the same with Perl. You know, if you go into any major company, you know, Pearl's not dead.
Yeah, it's not dead.
It's not
and
dead.
I will tell you, it does sound harder because what you're seeing is you're seeing me learn things as I go. It's a really, really steep learning curve. There's no two ways about that.
Yeah.
You know, unless you spit Python or C++ as your daytime job, the rest of this is going to be, you're going to have to learn that too.
Yeah.
Not just how they all interact.
So the thing is then that in the note of, you know, if something doesn't work, right, then you kind of screwed. That it's true, but I'm not sure it would be that much different if you don't use RAWs and instead use a SLAM algorithm that comes from one of those libraries, like the MRPT that I mentioned, right?
Yeah,
and there are others. There's like, again, there's a repository somewhere with all kinds of SLAM implementations, right? You're in the same boat to some degree, right? Because you're using that, and there's gonna be lots of parameters associated with it that you may have to tweak, and which has always been my challenge with some of the RAWs navigation stuff. There's so many parameters, and you know, if you're not an expert in it, you don't know how to tweak that for your platform. And so, you know, I think there's going to be less complexity if you take some of the raw stuff out of the picture and just use other building blocks, but you're still dealing with a situation where if that algorithm doesn't work right, you know, why is it not working right?
Well, like I say, this guy showed success doing the simple problem that he chose to solve. Okay, it's a very simple you know, he's only got a map of like 6 by 6. Okay, and the thing you realize is this complete map is being done in one go. Otherwise, where your robot is, where the goal is, it's all done in one go. So he can do the wave algorithm that goes back and tells him the path. It's not so clear that when you're only looking, say, at a 6 by 6 out of a 24 by 24 potential map, you know what I'm saying? You're actually having to shift the map as you go down the road. I guess you can put the whole map. It'd be really interesting to know how they do that on a Roomba. Because do they carry the whole map virtually? I mean, you know, you can only populate a certain portion of the map because that's all your sensors can see. And the rest of it's going to be all marked as 0. Or if
you're assuming it's building a map in the first place.
Well, in this case, they definitely are building a map.
Yeah, I know, but you've got to question how often that's necessary. You know, I think David would probably argue against building a map in the first place.
Oh yeah, he would never do
that. It,
yeah, you know, he would have me wall falling around and doing all of this good stuff, and that's fine. But for the particular problem I'm trying to solve, I'm in my kitchen, and I want to go into my hallway in my house, and the coordinates, that's final waypoint is something like minus 24, 25. Okay, so it's literally right where my robot starts. It wants to go through the wall. It really, because that's where the waypoint is. It wants to go straight through the wall, and so
you're trying to avoid sensors?
No, I want to use the sensors, and you know, there's nothing wrong with saying, okay, if I don't have a path, well, okay, first of all, you have to know you don't have a path. Okay, and then you have to figure out, well, okay, do I want to go wall following? Well, that's one possible. And I'm not saying that's wrong, but I would like to try the mapping approach, where it says, okay, there is a solution to this, or at least to get you closer, and then you keep updating your map as you go along and get around. I mean, it's just another way of doing it, and
sure.
And I'm just hoping that I'd like to see how hard or how simple I can make this. and it won't be as elegant as the motion of a behavioral robot, because that one is, you know, is turning a little bit here and a little bit there and going around, but it should key in on finding the waypoint faster. You know, it won't be kind of like lost in the wind and oh, there it is, and then head off. So we'll see. You know, David, I'm sure, would say this is the wrong way. Don't go that way. But we'll see.
It's the way I'm planning on going, so I'm hoping it works for you.
Yeah, I mean, we got to keep David on his toes, you know.
The hard part is updating the map, right, with real-time changes. So
no, actually, actually, that's not too bad. That's not. I don't think that's a big problem. I think the big problem is when you how big a map do you have? I mean, what do you do? Because you only see a little bit of the map at any given time, but you want it to be flexible. So, you know, we'll see.
Yeah, I mean, your map, I mean, when you use the term map, to me that automatically implies you're maintaining more than what you can see. I don't know what the right word would be for, you know, your visual and sensor horizon is a certain distance, you're right, but that's not your map. Your map is, to me, by definition, more than that. You're going beyond that, and you have, you know, history or predetermined information that was given to you where you've learned it along the way. Whichever way the map came about, it's bigger than the range of your sensors. Otherwise, I would call it a map.
Oh yeah, but what I'm saying is, I guess what I'm saying is, once you move out of that area, even though you may retain, you know, if you move your robot, what it can see moves. All right, retaining the old information may or may not be useful to you, because you don't know. It'd have to be updated for sure, because somebody could have moved, somebody could have walked into the position.
Yeah. Now, one thing that I found very helpful in the RAWs, and that's one of the pluses on the RAW side for me, is sort of the visualization tools they have, because when you have something up and running, or even if it's just a candid demo that runs in simulation, and you see some of this in action with the visualization tool, some of these concepts become a little clearer. And because so in the RAWs land, right, they make a distinction between the static portion of the map that you were either given, or you've learned it once and then you just called it a day with the map making, right? And then the parts that potentially updating, and so yeah, there are going to be pieces that you think are static and don't change, and other pieces that appear out of nowhere. But they have ways of dealing with that, right? In the RAWs, they call it a cost map, and a global cost map, and local cost map, and it's all just basically whatever they can see in real time and what they have stored in the map, right? They just it all feeds into the algorithm that tries to produce the most optimal path to your destination.
And I would imagine most of the RAWs mapping programs use LiDAR.
That's also true. Either LiDAR or similar fidelity sensor. You know, a camera based that gives you similar fidelity data. That's true. They seem to want that.
Well, I mean, if I was rich and had lots of money and I was building my $2,000 robot, that's definitely the way I would go. You know what I mean?
Yeah, but you don't have to. I mean, when I was trying to build this sort of thing from scratch a couple of years ago, I had mainly the sharp infrared sensor, and I had a couple of them around, sort of a 360-degree view. I don't know, maybe let's say 8 of them, right, in various directions. And if you have a couple of them, 8 or more, right, you are kind of approximating a LiDAR in the sense that you have a sensor array going in all the directions, and as long as you know what the direction of the sensor beam is relative to your robot, right, that's kind of what you need to know to update the map.
Well, the guy the guy that I was linked in, he's only got one sensor, He's got a sharp sensor on a servo, and he's going all right, forward, all left. So he's taking 3 reads. And then he's making a decision based on that, moving to the next step. So you're right. I'm thinking, Chris, that this is doable. And like I say, the first step is just to have the same functionality he has. Then I will understand the problem a lot better, I guarantee you. You know what I mean?
Yeah. So this is the sort of thing, we talked about simulation a lot at one time, right, with the line following. This is the sort of thing that I like, and I haven't done simulation in a while, but this is, if I were to try, I wanted to get, try some, if I wanted to try out some algorithm, and I don't know yet how the algorithm is going to work, I would probably do that in simulation first, rather than,
Oh, I agree.
Debug on the robot, because,
That's the reason, you were talking about Ross's simulation tools. They're great, no question. And a similar thing, that's the reason why I used an Autopilot, was because their mission planner it's great. You know what I mean? Yeah, I don't have the skill to create that, but I can use theirs, So I agree with you that simulation, and Ross, maybe it's time to stroke up Ron a little bit. He was going to do a obstacle avoidance simulation. Maybe I just poke him a few times and see if we can get him go on that. That might be useful too. Yeah, I don't know. I'm going to try this for another week or so before I go to Ross, I think.
I have some news.
Yes.
When you go
oh, that's cool. Thank you.
I've got 3 things. I have been investigating, as you know, trying to implement an I2C slave on anything, and the only one I've been able to find is the STM32 or the Pi board, and that turns out that I may end up buying one of those. There's the D series ones, which are the non-square ones. They're longer and run at 216 megahertz. So I'm kind of looking into actually buying one of those. And they even have an eMMC 4 gigabyte memory module you can plug underneath. But before I do that, I'm still kind of waiting for the RP2040 to perhaps implement that. It's not been done yet. But I have managed to, I can't quite get it up into there. Okay. I've managed to get libraries installed, so that little NeoPixel there is my first attempt at getting an actual library on the itsy bitsy RP2040 running, and that actually works, and is the first time I think that anybody in Adafruit even who makes this board has managed to get this thing running for some reason. So I'm kind of working towards getting MicroPython on that board running, and probably running it as a UART rather than I2C. Second bit of news is I just put in over $1,000 worth of $320 New Zealand in shipping charges just for 2 orders to GoBuilder for the beginnings of my Mars rover. This is my test bed in Imperial Servo City stuff, and now I'm going to go ahead and implement this in GoBuilder in Metric. And so I've bought the motors and the steering mechanisms and the assembly, but no chassis. Well, no, I've got the basic beginnings of the chassis, and that's like $700 just for that. So it's going to be a $2,000 or $3,000 robot by the time I'm done, sadly. And that's just for 4. I'm not going to try to do 6 right out the bat. So it's a 4-wheel steering robot is what I'm starting to work on. And third thing is I'm continuing to add behaviors to my craws. And so I can demo. Now, do I have to have it on the floor to get a gold star, or can it be on the bench?
Bench is fine.
Okay.
We'll let you do it this time, but
Bench
not
is fine.
It's a bench gold star.
All right, so here it is. Oh, I got to turn off I did this last time. I forgot to turn off the focus thing. Change background.
You get double points if you put it on the ceiling.
That's when you're working on the space station. Okay, so everybody can see that?
Yep.
Okay, so that's the KR01, and I just restarted it, so I've got to SSH into it. Hold on, KR01. Pardon me. Okay, start up the operating system. Okay, So now we are running, and I think I showed you the roam behavior. So roam behavior is this. So if the robot, let's see if I can do this. The robot is running in roam right now, and then as you move your hand towards it, it slows down to a stop, and then if you take your hand away, it goes up again. Now, so that's kind of the move forward behavior, and I need to stop that. Okay. Now you'll note that everything in this design, it doesn't really stop fast. It's got acceleration and deceleration. And so there's also now an avoid behavior on the bumpers, and there's also a mast sensor and 2 infrareds in the back. And those don't do anything at all unless the robot's backing up. And I don't have those quite running, but I do have the mast sensor, and that will just back up. So if you get close to the mast, it just backs the robot away from whatever that was. And that's the same behavior as on the bumpers. Although, because the bumpers have a center port and starboard, if you can't really see this, this would be something that would show up on the floor, but if I do the starboard side, it'll actually curve away from the obstacle, and same with the port side. So what I'm doing is actually changing actually, maybe you can see that. No, you can't. But the velocity of the motors is actually different if it's left or right, or port starboard. So I've now got this kind of bumper avoid. And then what I'm working on right now is on the oblique sensors. There's the center sensor and the oblique sensors. And on the oblique sensors, which are 25 degrees off center, what's going to happen is as you move closer to that, it will steer the robot away from whichever side it is. But if it gets as close as that same 25 centimeters as the roam behavior, it will then treat it as a bumper. So basically, if the robot gets within 25 centimeters on the left or right, it'll actually back away from that at an angle or in the center with the center prioritized. No, the center is deprioritized. So that's all coming together. And so my OS is actually getting pretty functional. I've got the backup, the mast and the backup infrareds are digital, so they're 15 centimeters. And the backup ones are only at play when it's backing up, of course. And so the idea is that if it starts to back up and it hits anything or sees anything at 15 centimeters, it'll stop, and I guess at this point stop confused and not know what to do. But I'm happy to say that my operating system is now actually functional, and it does run around, and I'm hoping to do a YouTube video of just letting it out on my deck at some point and see what it does. So,
great. Applause.
Yes.
It's been over a year in development. I know what David's going through because he rewrote his OS, and it's taken him a long time, and it's taken me. I mean, I had a functional robot over a year ago, and it hasn't been functional for a long time. So just getting it to the point where it actually runs again is quite nice. I've also got kind of, well, I guess I could show one more thing if I can. Let's see, what is it? Oblique. So this is a test of the oblique sensors. I'm going to turn off a little bit of lighting here. So what this is a visualization of the oblique behavior. So if you get over here, it basically ramps up the percentage of the lambda function that it puts on the left or the right motor. So as you get closer, it basically changes the value that it's putting on the motor to alter its behavior. So as I move between left and right, you can see that it's sensing my hand, and the distance that the visualization goes is a product of distance. So that is kind of the visualization of what the oblique avoidance will do once it's running. I'm not quite there yet, but it's getting there. So I can breathe a little bit because it actually works. Because for the last few months, it was sort of like, I didn't have anything working at all, and it's finally moving again, which is quite a relief. So anyway, that's it from me. Thank you for listening.
Very good. Very good.
Very good. Yeah. Anybody else?
I have one more quick little thing.
Sure.
Let me go to present mode here. I forgot that I saw this today, and I thought y'all would be interested in it. Let's see. I'm showing this astronauts in space thing now, and you can see, later I'll do that, you can see they've got this little ball here. Let's see if we have another angle on it. called Simon. Here we go. This Simon thing floats around, and they can talk to it, and it can use speech synthesis. Right now, it's using the IBM Watson, which means they have to send the input that it gets down to earth and get the answer back in order to transmit. In my opinion, not a very functional thing, but basically it's stuff that we're kind of trying to do ourselves with speech synthesis, and somebody's done it on the space station, and they're actually using it in this floating ball thing.
Didn't I see that a while ago, and they had to turn it off because it got way snarky and started insulting people?
I heard that Watson did because they had it open to the world, but I don't think it was this Simon thing.
Well, I think I thought I saw something happening on the space station where they had to turn it off.
Yeah, that could be. I don't know any of the history. I only know this one article.
So the same thing happened to Azure too. They turned on the Azure and they basically trained it on Reddit. Used Reddit to train it, and I'm like, that's probably not a grand idea. I mean, that's what I heard. I don't know that. I heard they trained it, so that could be true or false. I don't really know, but they trained it in a way they shouldn't have, and it took all of 30 minutes for them to take the whole thing offline.
Wow.
Yeah.
If you guys are interested, I can show the VBots LiDAR simulator, which you can get up and running in 30 minutes.
Okay.
I'll be done with this in just a second, and I'll let the screen go.
You think they
Okay, I'll show my screen here. So
hold on, Kumar. There's still something.
Oh yeah, okay.
And I don't hear sound either, by the way.
My name is Simon.
I don't know if y'all can hear sound, but now I can.
Simon,
we can.
I'm from Friedrichshafen at the Lake of Constance. It's a nice place. Simon, what can you do for me? I always aim to improve my performance. For that, I will send the survey answers after each experiment you want to do. Help me with the EPO crystallization procedure. The required equipment is shown on the screen. Are you ready to start?
So that's enough of that. It was an interesting thing that I just thought would be kind of cool. That certainly we should be implementing something similar to that soon. I'm currently working on or planning to work on things that will be able to do that sort of stuff. I don't know how much they're spending for that one. Mine won't cost that much. I waved my time on the table and let somebody else take over.
Okay, somebody was going to show a demo.
I don't know how to share.
There's looks like a rectangle with an arrow in the middle of it.
On the bottom bar?
Yeah. If you click on that, that, it'll say share. But now, when you see your screen, you got it. You got it.
So this particular thing, what I'm showing is a VBot simulator, and there's a robot moving here, and it has got a LiDAR, and it is detecting the obstacles, the distance of the obstacle from the location. So this one is nearer, this one is farther, this one is farther. And in order to get something like this done, all you go help, VBot's guided tour, devices. And in my case, I chose the LiDAR over here, LiDAR, and it brings it up. So depending on what sensor you want to choose, and you can go ahead and create the scene wherein you can create various obstacles, robots, sensors, and very, very easy to do. And the installation of this software takes about 30 minutes on a Windows 10. That's all it took me. So for those of you who are interested in simulation, especially I heard about SLAM and that we want to simulate what can happen with a LiDAR, this is one option for you.
So am I guessing correctly that on the right side of your screen it's showing the code that's running that demo?
Yeah, this is the controller code. This is the controller code, and you get controller code either in C or in Python. And over here is where you go ahead and add the objects. So you can create things, and over here, this particular robot which is here, which is this particular robot, if you go inside there, you can go ahead and add the controller for the LiDAR, and you can add the LiDAR as well. And not only can add LiDAR, you can add IR sensors, reflectance sensors, whatever you want.
Cool. Thanks a lot.
Yep. Nice.
So
Yeah,
have you
maybe it's
created,
for
Kumar,
some
have
of
you
you
created a simulation that where it represents your own physical robot?
Yeah, in fact, I created my robot. I've added sensors to it, and I've created the scenery. Like, for example, when I wanted to simulate the Mars robot, I actually created rocks on it and placed rocks. I can do all of that, and it's very, very intuitive. Add object, shape, take STL files, take texture files, add into that, and very, very easy VBots. And there is a Discord group on VBots, and you go there, and people are so responsive. In fact, I had a jetbot with me, and I wanted to simulate the jetbot inside my house. And when I tried to do that, it just fell to the floor and fell down. So what should I do for that? And immediately in the Discord channel, there are people who are able to respond, give you feedback, and make it running. And the thing is, like what Doug is trying to do, he's trying to find out a new topic. And instead of building it and doing it, you can simulate it and take the simulation and move it over. So just wanted to quickly throw it in over there for whoever is interested.
Thank you. Lots of food for thought. Anybody got anything else? Going. Okay. It sounds like we're going, guys.
So,
All
Doug,
right.
What about the next meeting?
Okay. Wait a minute. Before you're going. Yeah. Okay. Normally we'd have a meeting this Saturday. Okay. So it's not going to happen. So what we're going to do is have a flash meeting on the following Saturday with SRS. You can look at DPRG for details. I'll have a post out here in the next day or two. Okay, so no things this Saturday, something the Saturday after this Saturday. Okay? Anybody got any? Did that cover everything? Everybody know? And we like to have a good presence there because, robot clubs supporting robot clubs is a good thing. So, okay.
But we are planning to do the Tuesday.
Oh, next Tuesday, yeah, there'll be. Is there any reason why we wouldn't? No.
Well, just to tell them, the
Yeah.
FYI.
Yeah.
So yeah.
Next Tuesday we'll be here again. All right then, guys. So I'm stopping the recording.
I'm gone.
Bye bye.